The tanks are stocked every 2 months. So the one tank will be heavily loaded, one tank will be medium, and one tank will be light. All that water mixes, so the ammonia load is an average that's not really high. So half the water goes to what I said, which will get about 80% ammonia removal. If it enters at 1, it'll leave at 0.2. It maintains nitrite at 0.1 to 0.2. It has nitrogen, very clean water. And then the water is low in oxygen and high in carbon dioxide. So the CO2 strippers is a forced ventilated cascade aeration column. It's sucking air out through the column at 10 volumes of air per volume of water. And that fan isn't running now because we're at light load. But when this thing's really heavy load, CO2 is really critical. So that sucks out as much CO2 as it can and vents it from the building. And the water comes out saturated. And then we run through a low-head oxygenator right below it. The low-head oxygenator only needs this much pressure. And it will take the water to 200% saturation. And it dries the nitrogen out. So the fish won't ever get gas bubble trauma. We have a constant flow to the fish tanks, returns to the fish tanks. We have a pipe to every tank so that if one tank shut down, then we aren't changing the velocity in the other pipe. If it was one central pipe, we turn off the tank and then we get settling in the pipe. So we have one pipe per tank so that if I take one offline, it doesn't affect anything in the system. It's all isolated. And actually, economies of scale at 20-inch pipe, you lose economies of scale with bigger pipe. It doesn't get cheaper to go bigger. It gets more expensive to go bigger. So this made a lot of sense. So